This is an overview of the results of the Catalyst Analytics Server work. In this presentation, we will cover why are analytics important, how do analytics work, and the accomplishments of our project in this area, including a systematic analytics identification methodology, a large analytics library, an implemented versatile analytics server, and data and theory grounded analytics evaluations. First, why are analytics important? Deliberations on complex topics will inherently involve large crowds because there are many different kinds of required expertise and perspectives, and will also tend to generate big maps simply because the topics have a lot to them in terms of options and arguments. In this example, for example, 200 users discussed what use Italy should make of biofuels and created a map with roughly 2,000 posts. Given such large crowds and big maps, the question becomes, how can we guide these crowds to optimize the outcomes that they produce? For example, how can we guide contributors to identify the gaps in the current map and to fill them in? How can we help managers identify which parts of the discussion are progressing poorly and may need intervention? And also, how can we guide customers to identify which content is ready to be harvested? And analytics basically address the need that without being able to see where you're going, it's hard to steer. Analytics provide the window that allows us to steer the crowd. Analytics work in our system by collecting data from the activity of the crowd in a deliberation map and then running algorithms on it to produce two different kinds of outputs. One are metrics, which are numeric summaries of the activity in a deliberation, which can then be visualized in order to provide insight. A second output are alerts, which are customized notifications which notify users about what they specifically can do in order to produce a better deliberation map. So now let's review the accomplishments. The first was a systematic metrics identification methodology. And this is based on PCV, or Process Commitment Violation Analysis. This analysis works by first identifying the subtasks of the process we're concerned about, in this case, deliberation, and then identifying which goals would ideally be satisfied by each of the subtasks in this process, then identifying the ways that each goal could possibly be violated, and then finally identifying analytics which are able to assessing the progress towards each goal as well as the occurrence of each exception. In order to enable this, we developed an online analysis tool which allows users to enter the process steps, goals, exceptions, and associated metrics. And this was used to capture a large knowledge base of relevant metrics for crowd-scale deliberation. We then also developed an online prioritization tool which the members of the Catalyst Consortium used to prioritize the metrics that were identified using our systematic methodology. The outcome of this element of the work was to harness process commitment violation theory and crowd wisdom to systematically and comprehensively identify and prioritize the key analytics relevant to enabling effective large-scale deliberations. Accomplishment number 2 of our work was to develop a large analytics library. The library is too large to describe in detail during this presentation. This is a list. There were 80 metrics that were implemented by the system, and 3 examples of these include, first, the groupthink metric. Groupthink is the effect where a group that is trying to solve a problem converges too quickly on one option rather than considering several options in some depth before settling on an answer. The problem with groupthink is that answers that may have actually been superior would have been ignored because some other answer too quickly got the bulk of the group's attention. And with a deliberation map, this can be assessed quite straightforwardly. Is you look at the activity level for competing ideas for a given issue and then see how the inequality coefficient of the activity on those competing ideas changes over time. If it changes, if the inequality increases quite rapidly, as it does in the top example, then that's a signature of possible groupthink. If the inequality metric stays low for a substantial period of time, then that suggests that groupthink is not occurring. A second example of a metric is the maturity metric. The maturity of discussion would be quite difficult to assess in a conventional online deliberation, for example, in a web form, but by simply calculating simple topology statistics of the deliberation map, we can distinguish an immature discussion, such as the one on the left, versus a more mature one, such as the one on the right, which includes many more ideas, issues, and arguments. A third example of a metric is the contentious issue metric, in which we look at competing ideas and the arguments underlying them, and we see if the crowd, based on its arguments and the rating for the arguments, agrees substantially on one option versus the other. And this, again, is a fairly straightforward application of statistics, but would be very difficult to do in a conventional deliberation system. In addition to the 80 metrics, we also implemented 30 alerts, which are described in more detail in the project documentation. One example of an alert is informing authors about whether they have rated a post without looking at the underlying arguments. So, for example, imagine someone in this deliberation map had given a high rating to the idea that yes, carbon emission offsetting is a good idea, but had not viewed some of the relevant arguments. In that case, it is possible that their rating was ill-founded because they did not look at the underlying information. And again, in the particular context of deliberation maps, it's easy to detect this kind of problem and to notify the users of when they may have fallen prone to it. To summarize, the outcome of this aspect of the work has been to implement 80 metrics and 30 alerts of unprecedented power, which means that can recognize important phenomena in crowd-scale deliberation, which would be impossible to detect with conventional social media such as web forums. In conventional web forums, the analytic systems are limited essentially to looking at word frequency statistics, but the little bit of formalization made possible by deliberation maps goes a long way in terms of enabling more powerful metrics, more powerful analytics. A third accomplishment of our work has been to develop and implement a versatile analytics web service. It's a fully functional tool that runs on the web and that deliberation systems can interact with using the Catalyst interchange format. It's reusable in the sense that as long as the deliberation platform adheres to the CIF syntax, it can be used by any deliberation system, and we have demonstrated this by the fact that our analytics server is currently connected to 3 diverse deliberation platforms that were developed by different members of the Catalyst team. The fourth accomplishment of this work was an empirical and theoretical analysis or evaluation of the analytics. And we did 2 kinds of evaluations. The first was to assess whether or not the kinds of problems uh, that are included in that the important problems occur frequently enough for an alert system to be worthwhile. I mean, if, for example, that people tended not to make mistakes or to make gaps that alert system could detect, then clearly the alert system will not be adding much value. So we wanted to see how much value the alerts could actually add. And to do this, we looked at a particular alert, which is the one that checks for whether a user has rated a post without looking at some or all of the arguments underlying that post. And we looked at a real-life large-scale deliberation, which the one mentioned earlier, which involved 200 users and 2,000 posts. And what we found that almost everybody, roughly 86% of the ratings in the map were made while not having viewed at least some of the underlying arguments. And it turns out that there was even a non-zero percentage, roughly 6% of the ratings that were made while having not viewed all of the arguments underlying that post. And this is not necessarily just negligence on the part of the users, since they may have made the ratings before the additional arguments were added to the map. But in either case, it's clear that in the absence of an alert, an important kind of problem, in other words, rating without looking at the underlying arguments, in all likelihood would occur very frequently. A second kind of evaluation we did is to assess whether or not visualizations driven by metrics can make important deliberation patterns much more visible than they would otherwise be. And to illustrate this, we started with a sample real-world deliberation map about carbon emissions offsetting, which consisted of 2 ideas and a total of 6 arguments. Imagine that we have 2 different groups who had rated the elements in this map. And we could see the ratings that each of the users, in this case 8 users, made for each of the posts in the map. And looking at the table at a row of numbers, it may not be obvious what the emergent patterns are. And if we even look at the ratings histograms for each of the posts, we'll find that in all cases they have this pattern, so they're identical. But if we apply one of the metrics from the Catalyst server, in particular the support vector metric, which is a kind of eigenvector analysis, we could see that the ratings for the posts in group 1 do not cluster in any particular pattern. That's the scatter plot on the left. While in group 2, the ratings made by the users cluster into 2 distinct groups. Further, if we look at the weights on the most significant eigenvector, we can get an idea of which posts were critical in creating the divide between the 2 groups of users that appear in the 2 clumps in the second group. And if we visualize the argument map where the colors are related to the weights in the eigenvector, then we can get the insight that balkanization is taking place. In other words, that there's a split in the community, that one half of the community strongly supports the yes ideas and arguments, and the other half of the community strongly supports the no idea and arguments. So using the support vector metric, we're able to get insight into the community and its preferences that would be very difficult without this kind of visualization. So the outcome of this work includes a set of alerts, 30 of them, which can detect important deliberation gaps that would otherwise occur frequently based on our analysis. And also, we have developed metrics that can provide insights of unprecedented power compared to conventional social computing tools into how the deliberation is progressing. To summarize, the Catalyst Analytics Server provides a fully operational open source web service, a large library of analytics of unprecedented power and demonstrated utility, and a systematic methodology and toolset for identifying and prioritizing new deliberation metrics.